Alright, AP, this is sample exercise 4.071. We are determining the mass of product formed. When aqueous solutions of sodium sulfate and lead nitrate are mixed, lead sulfate precipitates. Calculate the mass of lead sulfate formed when 1.25 liters of 0.0500 molar lead nitrate and 2.00 liters of 0.0250 molar sodium sulfate are mixed. Go ahead and press pause now, because here come the solutions. So we got multiple steps here. First, identify the species present in the combined solution and determine what reaction occurs. When the aqueous solutions of sodium sulfate, which contains sodium plus 1 and sulfate minus 2 ions, and then lead nitrate containing lead plus 2 and nitrate minus 1 ions are mixed, the resulting solution contains the ions Na plus, SO4 2 minus, Pb plus 2, and nitrate minus 1. Since sodium sulfate is insoluble and lead sulfate is insoluble, again, table 4.1, solubility rules, solid lead sulfate will form. It'll precipitate out. Step 2. Write the balanced net ionic equation for the reaction. The net ionic equation is Pb plus 2 in the aqueous form reacts with sulfate minus 2 in the aqueous form to yield lead sulfate in the solid phase. Step 3. Calculate the moles of reactants. Since 0.0500 molar lead nitrate contains 0.0500 molar lead plus 2 ions, we can calculate the moles of lead plus 2 ions in 1.25 liters of this solution as follows. Again, why 1.25 liters? Oh, it's in the question. That's the volume of the lead nitrate that you started with. So we can understand, we can know how many lead ions we have by applying the volume that's been given, multiplying the volume that's been given by the molarity of the lead ions, but we're just writing it in the molarity equation format. Moles of solute over liters of solute. This simple calculation, 1.25 liters multiplied by 0.0500 moles of the lead ion over 1 liter. Liters cancel. We get moles of the lead 2 ion. We get 0.0625 moles of lead 2. So we have this amount of lead 2. Now let's move on and try to figure out how much sulfate we have. The 0.0250 molar sodium sulfate solution contains, right, 0.0250 molar sulfate ions. And the number of moles of sulfate ions in 2.00 liters of solution is, and you can do this in your head, I understand, but let's see the process here in case you get more difficult numbers in some future time. You got the 2 liters. We're multiplying it by the molarity of the sulfate ion. Again, for every species, for every single unit of the sodium sulfate, there's only one sulfate. So we simply take the molarity of the overall unit, and it's the molarity of sulfate. That is 0.025 moles of sulfate over 1 liter. And that gives us 0.0500 moles of sulfate. Moving on to step 4, determine which reactant is limiting. We've just calculated the moles of lead plus 2 and sulfate minus 2 that are available to react. But which one is going to limit how much of the product can be made? And again, according to step 2, if I can get that right, whatever. According to step 2, the product here is lead sulfate. So how much of this lead sulfate can we actually make from this amount of lead and this amount of sulfate? Because lead plus 2 and sulfate minus 2 react at a 1-to-1 ratio, again, according to that net ionic equation that you've already made, the amount of sulfate will be limiting because 0.0500 moles of sulfate is less than 0.0625 moles of lead. That's not that complicated. On to step 5. Calculate the moles of product. Since the lead plus 2 ions are present in excess, meaning there's more of the lead 2 ions, there's a 0.0125 moles too much extra that doesn't react. Only 0.055 moles of solid lead sulfate will be formed. Now we have moles of the product. We know how much of the product will be formed. It's 0.0500 moles of solid PbSO4. We're going to convert to grams of product. We have moles of product. Now we convert that mole value into grams. The mass of PbSO4 can be calculated using the molar mass of PbSO4. It's 303.3. Sure, you did that on your own already. Now we carry out a very simple stoichiometric calculation. We convert moles of lead sulfate into grams of lead sulfate, and we conclude that 15.2 grams of lead sulfate are produced when these two solutions are mixed.